In this video, I'll demonstrate how to do a conditional proof. This is going to look different than our direct proofs, and that's because our conclusion, that is the statement that we need to prove, is going to be a conditional claim. So the conditional proof is for a proof for a conclusion of an argument that consists of a conditional claim. So let's take a look at what we've got here. We've got lines 1 and lines 2. Both of these are premises. So these are the statements that we're going to work with to do a series of derivations using our rules of inference, rules of replacement, rules of equivalency to derive and eventually prove the conclusion. So premise 1 is given. If A, then B and C. Premise 2, line 2, if B or D, then E. And then we have a few ellipses over here, and then that slash mark, which indicates what comes next, is the conclusion, the statement that we need to prove. It might feel a little bit confusing to have a premise and the conclusion on the same line, which is why the conclusion is separated off by the slash mark here. So you'll see this form come up in all of our proofs, direct proofs, conditional proofs, indirect proofs. So we just need to get used to that. Line 1 and 2 entail the premises, and then the slash mark off to the right is the statement that we need to prove. When you look at our premises, you'll see that we can't use any of our rules of inference to get us anywhere. One of the things you'll notice with a conditional proof is that you can't get started here with either of these premises. You can't do a modus ponens or a modus tollens, even though these are both conditionals. We're just sort of stuck. So we have to start our proof by making an assumption. And we're going to call out that assumption by shifting over and saying that our third line is shifted over because we're making an assumption. And that assumption is going to be the antecedent of the conclusion's conditional. So we're going to assume A, right? That's the antecedent of this whole conditional. And we're going to indicate that this is an assumed conditional proof. Right? That is going to be our justification for that assumption, and it's going to be line 3. With that assumption, we can now start to use our rules of inference. So right underneath line 3, which is right underneath the slash mark for the conclusion, we can start to see that if we assume A, then we'll be able to use modus ponens to get the consequent B and C. So we'll write that in for line 4. B and C justified by lines 1 and 3, modus ponens. So now we should start asking, what can we derive from what's been given so far for lines 1, 2, 3, and 4? And we want to remind ourselves what we're looking to do here. At this point, we should start thinking about what we're trying to do here. We're trying to derive E when assuming A. So here's E over here, and that means if we can get B or D, we can apply the modus ponens rule of inference, and we can make that series of derivations. If A, then eventually we get E, and then we can discharge the conditional part of the proof, and we've proved if A then E. So looking at line 4, we need to be familiar with some new rules of inference. And our rule that's going to be helpful here is going to be the simplification rule. We know that if a conjunction is true, for line 4, this is a conjunction, we know that B and C are both true. So what we can know is that B is true. We can derive B from B and C because in a conjunction, both B and C need to be true. And we could justify B from line 4 using the simplification rule. SIMP is short for simplification. Now, line 6, what can we do? Line 6 is going to use the addition rule, which says that for any claim that's a disjunction, as long as we know that one of those disjuncts are true, we can add anything to it, and that whole statement is going to be true because you only need one side of a disjunct for the whole disjunction to be true. So from B, we can add or D. It's justified through line 5 using the addition rule of inference, right? Because if B is true, you can add anything to it. You don't need to know if D is true or false for the whole disjunction to be true. Now look what we have. Here's the antecedent of the premise in line 2, B or D. If B or D, then E. So now we can use the modus ponens rule to derive E, and that looks like this. So we'll justify this through lines 2 and 6, modus ponens, and now we have essentially completed the conditional part, this indented part, such that we've proven that if we assume A, we can derive E, which is the same thing as saying if A, then E, which is our conclusion. So now what we call discharge the conditional part of the proof, and we slide it back underneath the main line numbers, and we show that we've proven if A, then E, and that conclusion is justified using lines 3 through 7, conditional proof. And that's it. You've completed the proof.